Hello everyone, I am Dr. Anindita Roy. Today we are going to discuss about group theory. Before we start the session, let's play a game. Here we have two boxes, and if I ask you to organize the elements present in these two boxes, how will you solve that? Probably like this. I have separated them according to their shapes, like circle, square, and triangle. Furthermore, I can separate those elements according to their color, such as blue, green, and red. This result also suggests that before having any theoretical idea about group theory, we all have a practical sense to form different groups according to our basic aesthetic sense. Now, a group is a collection of elements which are interrelated with respect to certain rules. Those are closure law, identity law, associative law of multiplication, and inverse law. To explain these laws, let's consider some elements A, B, C which belongs to group G. Then, according to closure rule, multiplication of any two elements in the group is also an element of the same group. Again, the square root of any elements also be a part of this group. Next, identity law. According to identity law, one element in the group must commute with all other elements in group, leaving them unchanged. That element is known as identity and it is expressed by E. That means when E is multiplied with any other element in the group, let's say X is the element in the group G, then it will commute with that element, leaving that element unchanged. No change will occur with respect to the identity element. Next one is associative law of multiplication. According to that, AB into C is equals to A into B into C. Okay. Next one is inverse law. According to inverse law, the reciprocal of any element in the group is also part of that certain group. Again, we can state that the reciprocal of product of any elements in the group is equal to the product of reciprocal of individual element but in a reverse order. To explain this phenomena, we are using an example. Let's say A into B into C equals to D. So we have multiplied both sides with C inverse, B inverse, A inverse, and we are getting this mathematical derivation. Following this, finally we'll come to know that identity element equals to D into C inverse, B inverse and A inverse, which shows that ABC into C inverse, B inverse and A inverse equals to identity. This group can also be classified into three elements. Those are abelian, non-abelian and cyclic. In abelian group, elements are commutable with respect to each other. Okay, which means A dot B equals to B dot A. In non-abelian group, the elements are not commutable with respect to each other. That means B dot A is not equals to A dot B. To explain this factor, I am using one example. Here I have considered A and B two separate matrices, and we have done A dot B separately and B dot A separately. So A dot B multiplication is done by first row multiplied with first column. In that way, 1 into -1, -1, -2 into 2 equals to -4, plus 2 into 3 plus 6. In this way, first row, then first column, we are going to multiply in matrix and we get two different result, which shows A dot B is not equals to B dot A. Another important class is cyclic group. According to cyclic group, any element in that group is eligible to produce all other elements present in that particular group. I think it is easy to explain with respect to an example. Let's say a group G which consists of three elements, 1, omega and omega square. So I have taken omega to check whether this group is cyclic or not. If it is a cyclic group, then omega can be able to produce all other elements present in the group. So according to closure rule, omega into omega, that is omega square, is also a part of this group, which is true. That is omega square, it is there. Omega into omega square, which is also a product of two different elements in the group, that is omega cube. Omega cube equals to 1, which is also a part of this group, and 1 or omega square, 1 or omega cube into omega means omega to the power 4, which is nothing but omega cube into omega, that is omega. That means 1 omega and omega square, only this three element is possible with respect to any of this element. That's why this group is known as cyclic group. Okay, so all cyclic groups are abelian, but the reverse one, that is all abelian groups, are not cyclic. Order is one characteristic of a group, which means the number of elements present in a group. So in this cyclic group, what is the order of this cyclic group? That is 3, because the number of elements present is 3. If we combine all the algebraic properties of a group in form of a table, then it will form a group multiplication table. It is very important to know the representation of group multiplication table, or GMT. It is actually a Latin square where each row and each column in the GMT represents each of the group element only once. Thus, each row and column is a rearranged list of the group elements. So I have used the previously discussed group, which consists of three elements, 1 omega and omega square, to form a group multiplication table. Here I have kept these three elements row wise, then column wise. Here is the name of the group we have to write in the intersection point here. Then simply multiply with respect to row and column, and we are going to get this table. 1 into 1, 1, 1 into omega, omega, omega square, this one omega into 1, omega, omega into omega, omega square, then 1, because it is omega cube, which is nothing but 1. So from this group multiplication table, we will come to know that each elements are present in each row and column without any other repetitions. Next is the concept of subgroup. Subgroup is a small group present in a larger one. So it should follow the Lagrange's theorem. What is Lagrange's theorem? It is nothing but the order of a group is divisible with the order of a subgroup. Okay, H is the order of group and G is the order of subgroup, which is divisible with respect to the order of subgroup. Subgroup can be divided into two segments. One is trivial, another one is non-trivial. Trivial, the order is 1. That means only one element can present in trivial subgroup, and that element is E or identity. In non-trivial subgroup, the minimum order of a non-trivial subgroup is 2, and the presence of E or identity is inevitable in any of these subgroups. It may be trivial, it may be non-trivial. At least one element in these two subgroups is E or identity. In this path of discussion, another concept we need to know, that is class. So to understand the concept of class, we need to understand the concept of similarity transform. We can explain mathematically this concept. If A and X are two elements of a group, then X inverse A into X equals to B, which is also an element in that certain group. Then B is similarity transform of A by X, and A and B are conjugate to each other. A complete set of elements that are conjugate to one another is called class of the group. The elements of class will follow certain rules, and those are: every element is conjugate with itself. That means if A and X both are present in a same group, then A equals to X inverse A into X. That means A is similarity transform of A with respect to X. That means every element is conjugate with itself. If A is conjugate with B, then B is also conjugate with A. And the next one is, if A conjugates with B and C, then B and C are conjugate with each other. Certainly, the Lagrange's theorem is also valid for a class in a group. That means the order of a group is divisible with respect to the order of a class, which is an integer. In this session, we have discussed about the basic idea of group theory. In the next session, we will discuss about molecular symmetry and symmetry elements. In that session, we will come to know how group theory is important in chemistry with respect to molecular symmetry and symmetry elements. Till then, bye.